Google just published a specification that fits on a single page. No product launch, no pricing page, no keynote, just a one-page document and a folder of plain text files, and a claim that has the entire AI world arguing that this small, boring format can replace the vector database you spent months building. The format is called OKF. And the reason it's controversial isn't that it's complicated, it's that it's almost insultingly simple, a directory of Markdown files. That's the whole thing. That's what's supposedly coming for a technology stack worth billions. So let's settle it properly. By the end of the next 20 minutes, you will understand exactly what Google's open knowledge format is, down to the actual files on disk. You'll understand what RAG really does and why these two keep getting pitted against each other. You'll know precisely where the folder replaces the database is genuinely true, where it's overselling, and the part that usually gets skipped, where RAG still wins and always will. And you'll leave with a real decision framework. For your project, which one do you actually reach for? No equations, no filler. Just the clearest explanation of OKF on the internet. Let's earn that claim. First, we have to talk about the problem, because OKF makes zero sense until you feel the pain it's solving. And it's a pain every single person building with AI has hit. Here's the situation. You have a powerful AI model. It's brilliant at reasoning, but it knows nothing about your world. It doesn't know that your orders table joins to customers on customer ID. It doesn't know that your company's definition of active user excludes anyone who signed up in the last 7 days. It doesn't know your deployment runbook, your deprecated APIs, or the tribal knowledge living in one senior engineer's head. The model's raw intelligence is capped not by how smart it is, but by how much of your context it can actually see at the right moment. Now, where does that context live today? Everywhere and nowhere. Some of it's in a wiki, some in Notion, some in code comments, some in a metadata catalog, some in Slack threads. Some of it was never written down at all. It is scattered across a dozen incompatible systems, and none of it travels with your code or survives a fresh conversation with the model. So every developer, every agent, solves the exact same problem from scratch. How do I feed this model the right facts in a form it can use? That problem has a name: context assembly, and it is quietly one of the hardest unsolved problems in applied AI. For the last couple of years, the dominant answer to that problem has been 3 letters: RAG. So before we can talk about what might replace it, we have to actually understand it, because you can't judge a challenger without knowing what it's challenging. RAG stands for Retrieval Augmented Generation. Here's how it works. In plain English, you take all your documents, manuals, wikis, tickets, whatever, and you chop them into small chunks. Each chunk gets run through an embedding model, which turns the text into a long list of numbers called a vector. That vector is a coordinate in a kind of meaning space, where chunks about similar topics land near each other. You store all those vectors in a specialized vector database: Pinecone, Qdrant, and Friends. Then, when a user asks a question, you embed the question into the same space, and you ask the database, which chunks are nearest to this question? It hands back the top few closest matches. You staple them into the model's prompt, and the model answers using them. That's RAG. And it is genuinely powerful. It let people build chat with your documents over millions of pages for finding relevant needles in an enormous haystack based on semantic similarity. It's still excellent. Keep that sentence in mind, based on similarity, because it's going to be the crux of the entire OKF versus RAG story. Because RAG has real structural weaknesses, and anyone who shipped it in production knows them intimately. Weakness 1, it retrieves by similarity, not by truth. It finds chunks that sound related to your question, which is not the same as the chunks you actually need. Ask about your refund policy, and it might hand you 3 paragraphs that mention refunds but miss the one authoritative rule. Weakness 2, chunking mangles structure. Slice a document into 500 token pieces and you shred the relationships. The table gets separated from the definition that explains it. The step 3 of a runbook gets divorced from step 1, weakness 3. It's a whole pipeline to build and maintain embedding models, a vector database, a chunking strategy, a re-ranking step, infrastructure that has to be fed and watered forever, and weakness 4, it's opaque. When RAG gives a wrong answer, figuring out why the right chunk didn't surface is genuinely painful. So the field has been quietly asking, what if for a lot of use cases there's a simpler way? And that question is where OKF walks in. Okay, deep breath. Here's what OKF actually is, precisely from Google's own specification, not the headline version. OKF stands for Open Knowledge Format. It was published by Google Cloud's Data Cloud team in June 2026 as version 0.1 in a public repository called Knowledge Catalog under the Apache 2.0 license. And here's the single most important sentence in this entire video. So I'm going to say it slowly. OKF is not a product, not a service, not a platform, not a database, and not a runtime. OKF is a format. It is a set of agreed-upon conventions for arranging plain text files in a folder. That's it. That's the whole thing. Specifically, an OKF bundle is a directory of Markdown files, each with a small block of YAML front matter at the top. Each Markdown file represents one concept, one table, one metric, one dataset, one playbook, one API. The file's location in the folder is its identifier. The files link to each other, like a wiki, forming a graph of connected knowledge. And the entire version 0.1 specification, this is real, fits on a single page. It has no schema registry, no central authority, no required SDK. In the spec's own words, if you can cat a file, you can read OKF. If you can git clone a repo, you can ship it. Let me make that concrete, because a folder of Markdown files sounds almost insultingly simple. Imagine a folder inside it, a file called customers.md, at the top a little YAML header, a title, a type, say, table, maybe a few tags. Below that, plain English and Markdown, this is the customers table. Here's what each column means. Here's the fact that it joins to orders on customer ID, and here, as a Markdown link, is the related metric active users, which lives in its own file. An agent opens that folder, reads the file, follows the link to the next concept, and builds an understanding by walking the graph, deliberately, like a person browsing a well-organized wiki. Google calls this pattern progressive disclosure. The agent starts at a root index file, reads only what it needs, and follows links deeper only when the task requires it. And I want to show you just how minimal the actual specification is, because the minimalism is the entire design philosophy. The spec defines a small handful of things, and then deliberately stops. It reserves two special file names, a root index file that acts as the entry point an agent reads first, and a metadata file that describes the bundle itself. It defines the YAML front matter block, and it mandates exactly one required field per document, essentially, a name for the concept. Everything else, the types, the tags, the link vocabulary, how deep the structure goes, is left entirely to the producer. That's not laziness, it's a strategic choice. The spec's authors are betting that the right move is to standardize the container first and let real usage teach the community what conventions the contents actually need. Standardize the box now, argue about what labels go on the box later. In a field where a dozen incompatible conventions were emerging every month, agreeing on the box alone is genuinely useful, and it's small enough that adoption costs almost nothing, which is exactly how formats actually win. And now you can see the contrast with RAG snapping into focus. RAG retrieves fragments by similarity and hopes the right ones surface. OKF hands the agent a pre-structured map. It can traverse with intent. One is a search over a pile of shredded paper. The other is a librarian handing you an organized, cross-referenced binder. That is the real technical difference underneath all the folder beats database hype. Let me walk you through what that actually looks like in motion, because seeing an agent use OKF makes the whole thing click. Picture a coding agent given a task. Add a column to our revenue dashboard that shows active users per region. With a RAG setup, the agent embeds that request, pulls back the top few chunks that sound similar, maybe a paragraph about revenue, a snippet about users, a fragment about a region column from an unrelated table, and tries to stitch a plan out of pieces that may or may not fit together. With OKF, the agent instead opens the root index file, sees an entry for revenue dashboard, and follows the link. That file says the dashboard is built on the revenue metric and links to it. The agent follows that link. The revenue metric file defines the exact formula and says it joins to the customers table. The agent follows that link. The customers file defines active users precisely, excluding signups from the last 7 days, and gives the region column and the join key. In 4 deliberate hops, the agent has assembled a complete, correct, authoritative picture. Not because a similarity score got lucky, but because it walked a map that a human curated to be true. And if any of those definitions were wrong, a developer would have caught it in the pull request that introduced the file. That's the difference between hoping and knowing. That's why, for this kind of structured task, the folder genuinely is better. Now, where did this idea even come from? Because this is the part that gives OKF its credibility, and it almost never makes it into the headlines. OKF didn't spring from nowhere. It's Google formalizing a pattern the community already invented. In April 2026, Karpathy, the co-founder of OpenAI, one of the most respected voices in the field, published a short note describing what he called the LLM-wiki, the idea that a language model can maintain a Markdown knowledge base the way it maintains code. His insight was beautiful and simple. The reason humans abandon personal wikis is the bookkeeping, updating cross-references, keeping links current, editing many files when one fact changes. That bookkeeping is tedious for us, and it's exactly what LLMs are good at. Models don't get bored. They don't forget to update a cross-link. They can edit 40 files in one pass. That pattern was already everywhere under a dozen names. The Claude MD and Agents MD files you drop in a repo. Obsidian vaults wired to coding agents. Metadata as code repositories, every one of them was the same idea. A folder of context an agent reads, and every one of them was bespoke and incompatible. A bundle built for one agent didn't work with another. OKF's entire bet is that the missing piece was never a smarter database. It was a standard, a shared container, so that knowledge written by one producer can be read by any agent without custom integration work. That's the whole ambition, not to reinvent knowledge, but to make it portable. So let's directly answer the question in the title. Is the folder replacing RAG? Here's the honest three-part answer: the real, the hype, and the part nobody tells you. Part 1, what's real? For a huge and growing class of problems, OKF genuinely is a better fit than RAG, and the hype has a real foundation. When your knowledge is structural, relationships, definitions, schemas, the way concepts connect, a traversable graph of Markdown beats, similarity search, hands down, an agent that needs to know how your tables join, what your metrics mean, and which runbook to follow does not want 3 fuzzy chunks that mention those things. It wants to walk a clean map. For giving an AI agent your curated, authoritative company knowledge, the stuff that has to be right, not just related OKF, is a genuinely better primitive, and the practical wins are real. It lives in Git, so your agent's knowledge is version controlled and reviewed in pull requests right alongside your code. It avoids context bloat, because the agent loads only the specific nodes it needs instead of one giant dump everything context file. It's human readable and human editable, because it's just Markdown, and there's zero infrastructure, no embedding pipeline, no vector database to run. For structured, curated, authoritative knowledge, that's not hype. That's a real improvement. Part 2, what's hype? The folder replaces RAG and vector databases are dead. Those are thumbnail claims, and they oversell it in 3 specific ways. First, OKF is version 0.1. It is, by Google's own framing, a starting point, not a finished standard. The spec deliberately standardizes the container, the folder layout, the file format, 2 reserved file names, and exactly 1 required field, while leaving the actual vocabulary, the meaning, mostly to the producer. Analysts have a precise phrase for this. OKF delivers structural interoperability, not yet semantic interoperability. In plain English, OKF guarantees any agent can find and read your files. It does not yet guarantee 2 agents will interpret them the same way. That's a real limitation, and it's the whole reason later versions exist. Second, OKF is not magic. It's only as good as the knowledge you put in it. A folder of badly written, out-of-date Markdown is just as useless to an agent as a badly built RAG pipeline. Someone still has to curate it. Third, and most importantly, it does not actually kill RAG, which brings us to the part nobody tells you. Part 3, where RAG still wins and always will. And this is the part that gets left out of the excitement entirely. OKF is built for curated, structured, relatively stable knowledge, the concepts, the definitions, the maps. But a giant amount of the world's useful information is none of those things. It's vast, it's unstructured, it's long tail, and it changes constantly. Think 10 years of support tickets, a 1,000,000 document research archive, every message in a company's history. You're never going to hand curate a clean Markdown concept file for each of 10 million documents, and you wouldn't want to. For finding a specific needle in a massive, messy haystack, based on semantic similarity, retrieval is still exactly the right tool. That's RAG's home turf, and OKF doesn't touch it. So the truthful headline isn't OKF replaces RAG. The truthful headline is OKF and RAG solve different halves of the context problem, and the best agent systems will run both. And this isn't my spin, it's what Google's own documentation and the specs analysts say directly. Many agent stacks will use OKF for relational, structural context, and retrieval for long-tail lookups. OKF gives the agent its map of what's true and how things connect. RAG lets it search the vast archive when it needs a specific fact that isn't on the map. One is the agent's structured memory. The other is its search engine. Pitting them against each other makes a great thumbnail and a bad architecture. And there's one more advantage of OKF that deserves its own moment, because it's the one that quietly matters most to real teams. It's Git-Native. Think about what that unlocks. Your agent's knowledge now lives in the same version-controlled repository as your code. When a developer changes how the orders table works, they update the OKF concept file in the same pull request, and a reviewer approves the knowledge change right alongside the code change. Your agent's understanding of your system stays in sync with the system itself, automatically through the workflow your team already uses every day. Compare that to a vector database which drifts out of date the moment someone changes something and forgets to re-index. With OKF, keeping the AI's knowledge current stops being a separate maintenance chore and becomes a side effect of normal engineering. History, blame, diffs, review, rollback, every tool Git gives you for code, you now get for your agent's knowledge for free. For a lot of teams, that alone, not the RAG comparison, is the reason to care. It also connects directly to where the agent ecosystem is heading, which longtime viewers of this channel will recognize. We've covered MCP, the Model Context Protocol, the standard that lets agents plug into tools and data. OKF is the natural companion to that world. MCP is how an agent connects to things. OKF is a clean, portable format for the knowledge it reads once connected. An MCP server handing an agent an OKF bundle is a very natural pairing, and it's exactly the curated source of truth an agent reads and updates over time, direction that production agent systems are converging on OKF. isn't a competitor to that ecosystem, it's a missing puzzle piece clicking into place. Let me give you the decision framework, because this is the practical payoff. The thing you can actually use tomorrow. Ask yourself 3 questions about your knowledge. 1, is it structured or unstructured? Relationships, definitions, and schemas lean OKF. Sprawling prose and archives lean RAG. 2, does it need to be authoritative or merely relevant? If a wrong answer is unacceptable and you need the one true definition, curate it into OKF. If close enough, here are some related passages is fine. RAG is great. 3, is it stable or constantly churning? A few hundred core concepts you can maintain by handsuit. OKF, 10 million ever-changing documents demand retrieval. Most real systems land on both, and now you know exactly which knowledge goes where. That single framework will serve you longer than any X is dead headline ever will. Now, how do you actually use OKF today practically? This is refreshingly undramatic, which is a point in its favor, because a bundle is just Markdown. There are 3 common paths. 1, publish an OKF bundle alongside your existing website or docs. You're literally just adding a folder to a repo. 2, have an agent generate it for you. One of the genuinely clever demos from Google is an agent that walks a BigQuery dataset and drafts an OKF concept document for every table and view, then a second pass that crawls your authoritative docs and enriches each concept with schemas and join paths. The bookkeeping Karpathy talked about, done by the machine. 3, wait for your tools to adopt it. And this is the sleeper, because OKF is an open format. The biggest beneficiaries may end up being everyone downstream of tools like Obsidian, Notion, and Hugo if they add native OKF import and export. Independent developers are already shipping OKF support in open source projects. The low-risk move the analysts recommend, take one team's documentation, build a small OKF bundle around it, point an agent at it, and see if it reads that better than the wiki it replaced. It's a weekend experiment, not a migration. Let's zoom out, because OKF is a small spec pointing at a very big shift for 2 years. The entire industry treated the context problem as an engineering problem. Build a better retrieval pipeline, a bigger vector database, a smarter chunking algorithm. OKF represents a different bet, that the answer isn't a heavier machine, it's a lighter standard. That the winning move is not a more sophisticated way to search your chaos, but a simple, shared, boring format for organizing your knowledge so agents can just read it. There's a reason this rhymes with everything else this channel has covered lately. Calibri, don't build a bigger GPU, stream from the SSD you have. Open weights, don't rent intelligence, run it. Free gateways, don't pay for convenience, route it. And now OKF. Don't engineer a pipeline to guess at your knowledge, just write it down in a folder the agent can walk. The pattern of 2026 keeps repeating. The breakthroughs aren't getting heavier and more expensive. They're getting simpler, more open, and closer to something you can hold. OKF is the context problem's version of that same idea. The missing piece was never a fancier database. It was a folder everyone agreed on. And whether OKF specifically becomes the standard or just the release that named the layer everyone was missing, honestly matters less than the direction it points. Production AI agents are moving away from rederiving the same facts over and over and toward reading a curated version-controlled source of truth that lives right next to the code. That's where this is all heading, with OKF or with whatever it inspires. Google didn't release a folder. It released an argument about where agent knowledge should live, and that argument is going to outlast version 0.1. So here's my question for you, and I'll pin it below. Are you Team OKF or Team RAG, or, like most serious builders, Team both? And more specifically, what's the knowledge in your project that an agent keeps getting wrong? Is it structured context that belongs in a folder, or long-tail lookup that needs retrieval? Tell me what you're building, and the most interesting answer might become the next deep dive on this channel. Every source, Google's official OKF specification in the Knowledge Catalog repository, Karpathy's original LLM-wiki note, and the analyses I cited is linked in the description so you can read the spec yourself. It really does fit on one page. That's the standard on this channel. The real explanation sourced in plain English every single day. If you'd rather understand the tools everyone else just hypes, subscribe. I'll see you in the next one.